Hey there, 6th grade time travelers, and welcome to today's Explainer. I'm absolutely pumped you're here because today we are going on a massive, imaginary global field trip across our spinning Earth. We're going to become time travel detectives and uncover the hidden mechanics of how our world keeps time. I mean, have you ever called a friend or a family member who lives in another country and realized they were eating dinner while you were just pouring your morning cereal? It feels completely bizarre, right? Well, by the end of this adventure, you'll know exactly why that happens and how to figure it out yourself.
So grab your detective hats for a second, because here is our main mystery for today. How on earth can it be exactly 12 p.m. lunchtime in London, but 5:30 p.m. almost dinner time in India at the exact same moment? Think about that. It's the very same exact second in the universe. You are existing at the same time as someone in India, yet the clocks in those two places are telling completely different stories. Is it some kind of geographic magic? Nope. It is just brilliant geography and math working perfectly together.
All right, Section 1, the spinning Earth. Okay, so to solve this, we got to look at the Earth itself. Now, our planet isn't actually a perfect sphere. It's what we call a geoid, which basically means it's a bit squished at the top and bottom, kind of like a slightly flattened ball. But for our time travel mission today, just picture the Earth as this giant, magical spinning top that's constantly twirling in space. And just like a skater pulling off a massive spin in the air, when our giant Earth makes one complete rotation on its axis, it's turned a full 360 degrees.
Now, how long does that massive 360-degree spin take? You probably nailed it already. It takes exactly 24 hours. And that 24-hour twirl is literally what gives us day and night. As this colossal top spins, different parts of the globe turn to face the warm, bright sun, while the other side rotates away into the dark, starry night.
So, how does all this give us our secret time travel math code? Well, it's actually beautifully simple. If we take our full 360-degree circle of the Earth and divide it by those 24 hours in a day, we get exactly 15. That right there, that is a super important number for a time detective. It means the Earth rotates exactly 15 degrees every single hour. Literally, every time the Earth turns 15 degrees, click, 1 full hour goes by on the clock.
To keep track of those 15-degree jumps, scientists and mapmakers created this invisible grid over the Earth using lines of longitude. Imagine lines of longitude just like the slices of an orange. They're imaginary semicircles running straight down from the North Pole all the way to the South Pole. These vertical slices help us measure distance east and west across the planet, but more importantly for us, they are the secret lines that actually control our clocks.
Which brings us to Section 2, the global starting line.
Okay, if we have all these orange slice lines covering the globe, where do we actually start counting? Well, back in 1884, countries from all over the place got together because, believe it or not, everyone's train schedules were getting totally messed up. They desperately needed one single starting point for time. So they agreed that a special line passing right through the famous Royal Astronomical Observatory in Greenwich, London, would be the official 0 point. We call this the prime meridian, or 0 degrees longitude. It is the absolute starting line for world time.
Now, since the Earth rotates from west to east, the sun always rises in the east first. So here is our golden time travel rule. If we travel east from London, we're hitting the fast forward button on our time machine. For every 15 degrees we go east, we add 1 hour. We literally gain time. But if we fly west, we hit rewind. Every 15 degrees west means we subtract an hour, essentially losing time compared to those clocks back in London.
All right, armed with our fast forward and rewind buttons, it's time for Section 3. Next stop, India.
This brings us right back to our original mystery, and it brilliantly shows exactly how Indian Standard Time works. Step 1. India picked a central longitude line of 82.5 degrees east, measured near a town called Mirzapur, to be its official clock. Step 2. Time for our secret math code. We divide that 82.5 by our magic number, 15. The answer? Exactly 5.5. Step 3. Because India is east of London, we press that fast forward button by 5.5 hours. That is exactly why when it's 12 p.m. in London, you just add 5 hours and 30 minutes and boom, it's 5:30 p.m. in India. Mystery officially solved.
Oh, and here's a super fun historical fact for you. About 150 years ago, British tea planters in Assam realized the sun was rising really early in their specific area. To get more daylight for picking tea leaves before it got dark, they completely invented their own clock. They called it Chai Bagan time, or tea garden time, and they set their local clocks a whole hour ahead of standard time, just to squeeze in more sunshine. Today, India uses just one standard time, but you gotta admit, changing clocks just to match the sun is pretty clever. Moving right along to Section 4, countries with many clocks. So India is a massively big country, but uses just one clock. But check this out. The USA uses 5 to 6 standard time zones. And Russia is unbelievably wide and uses anywhere from 9 to 11 time zones depending on the year and the local laws. Why on earth do they need so many? Well, if a country stretches across thousands and thousands of miles, the sun is shining on the East Coast hours before it ever hits the West Coast. If Russia only had one clock, people in the East might be eating their morning breakfast while it's pitch black midnight outside. Having multiple time zones basically stops the sun from accidentally rising at noon on your alarm clock.
Okay, hold on tight because we are plunging right into the middle of the Pacific Ocean for Section 5, the magic dateline.
Meet the International Dateline, or the IDL. If the prime meridian in London is the starting line at 0 degrees, the IDL is on the exact opposite, far side of the planet at 180 degrees longitude. But this isn't just where the hours change. This is the magical boundary, where the calendar day officially changes. It literally separates today from tomorrow.
Get ready for some pure time travel magic. If you are on a boat and you cross this line going east, you literally go back to yesterday. You subtract an entire day from your calendar. But if you turn that boat around and cross it going west, you jump a full 24 hours straight into tomorrow. You add a day. It is the only place on planet Earth where you can instantly jump between Tuesday and Wednesday with a single step.
But wait, if you look closely at a globe, you'll spot something super strange. All those longitude lines we talked about earlier, our orange slices, are perfectly straight from pole to pole. So why does this one specific line, the International Dateline, randomly zigzag all over the ocean? Well, it's all about keeping things organized for the people who actually live there. Just imagine an island nation sitting right on that 180-degree line. If the line was perfectly straight, the left side of the island would be living in Tuesday, and the right side would be in Monday. You could walk across the street to your friend's house and literally change the day of the week. To avoid that ultimate calendar confusion, mapmakers cleverly drew the line to zig and zag around islands like Polynesia and Kiribati, so neighbors can always agree on exactly what day it is.
And there you have it. We've traveled from a giant 360-degree spinning top of a planet, figured out our 15-degree hour slices, started our clocks at the 0 point in London, fast-forwarded our way to India, and literally jumped across entire days in the Pacific Ocean. Honestly, geography is just the greatest adventure you can take without ever leaving your seat.
To wrap up our explainer today, I want to leave you with a massive brain teaser. Imagine you are swimming right out there in the Pacific Ocean. You manage to put your left arm exactly on the west side of the International Dateline, where it's Wednesday, and your right arm exactly on the east side, where it's Tuesday. What day is it for you? Think about that awesome paradox as you go about the rest of your day. Thanks so much for joining me on this incredible geographic journey. Keep asking questions and keep exploring.